Hello, my name is Zishan, and today we're going to look into another question from kinematics. And the problem here is that there's a small bar which is sliding down an inclined plane, which is forming an angle of alpha with the horizontal. And the friction coefficient here is variable. Uh, it is given by k is equal to a into x, where a is a constant and x is the distance covered by the bar. So this is the diagram here. This is the bar, and let us assume that it has a mass m and the inclined plane with an angle alpha. So we will look at the free body diagram of the block. So these are the forces acting on the block: mg sine alpha, mg cos alpha, the reaction, and the friction k into r, which where k is the coefficient of friction and is replaced by ax and obviously r. There are a couple of things that we need to find about the motion of this bar. The first thing that we need to find is the distance it travels. Second, we have to find the maximum velocity this bar achieves. Obviously, let us say it starts from some point. Let us say it starts from here, it ends here, and here the velocity v is equal to 0. Here the velocity is also equal to 0. So there is a point somewhere in between where it has achieved a maximum velocity. The velocity goes on increasing, and then it decreases to 0. So we are going to talk about the distance and maximum velocity. First of all, let us write the equations of motion for this body. Let us consider the acceleration in the direction of the plane, along the plane, along the plane. Let us assume that the acceleration has a value equal to w. I would have taken a, but it is going to confuse us with the a here in the formula for coefficient of friction. So I'm going to assume it to be w. So writing the equations for motion of this bar along the plane, we have this turns out to be mg sine alpha minus ax times r here is equal to mg cos alpha. These two forces must be equal, is equal to m times w. Now, what we can do here is we will replace w, the acceleration, with this term v dv by dx. We have seen in the last problem y is acceleration equal to v dv by dx. Okay, now m from all the sides cancels, and we have v dv is equal to g sine alpha dx minus A G cos alpha x dx is x dx. That's it. This implies that we can integrate both the sides from a velocity 0 to say v, and v dv is equal to from a distance 0 to a distance x g sine of alpha dx minus cos of alpha x dx. This gives us v square by 2 is equal to, so this is the relation. Also, this can be rewritten as v square is equal to 2g x sine alpha minus ag x square cos of alpha. So we have a equation here. Now the point is we have to find the distances it travels. So um, let us say it travels a distance x. The relation between v and x is given. At the point it stops, the velocity v in the first equation that we've got is equal to 0 is equal to 2gx sine alpha minus ag x square cos of alpha. This implies 2 sine alpha is equal to ax cos alpha. This implies that tan alpha is equal to 2 tan alpha divided by a is equal to x. So we have found the distance it travels before coming to rest. Now we will come to the second part of the problem, the maximum velocity. The maximum velocity. Okay. From equation 1, we already have the relation between v and x. We have v square is equal to, so this here is the relationship between v and x. V and x. Now, for velocity to be maximum, the differentiation of this velocity with respect to x must be equal to 0 at some value of x. And we are going to find that value of x first. So it's going to be d by dx of v square is equal to 2g sine alpha minus 2ag x cos alpha equal to 0. This implies that sine alpha minus ax cos alpha is equal to 0. This implies that sine alpha is equal to ax cos of alpha, which gives us x is equal to tan of alpha by a. So we have found the value of x at which the velocity v is maximum. So we're going to use this x, this value of x, and find out the value of maximum velocity. Putting, let us name this once again. This is equation 1. Put in equation 1. V square is equal to 2g sine alpha times tan alpha by a. We have replaced x by tan alpha by a minus ag cos alpha into tan alpha by a whole square. This implies that v square is equal to 2g times sine alpha into sine alpha divided by a cos alpha minus ag cos alpha into sine alpha divided by a cos alpha whole square. So this becomes v square is equal to 2g times sine square alpha divided by a cos alpha minus ag cos alpha into sine square alpha divided by a square cos square alpha equal to, this implies that v square is equal to, which can also be written as g by a sine alpha tan alpha. This implies that v maximum is equal to root over g by a sine alpha tan alpha, value of the maximum velocity. So in this problem, we found out the distance the bar travels before it stops. It's 2 tan alpha by a. Also, we have calculated the value of the maximum velocity it achieves here. I hope this has helped you. The only concept that we have used is the fact that acceleration can be replaced with v dv by dx. This fact and rest we have used integration and the concept that a function v reaches its maximum value when its differentiation with respect to x is equal to 0. There's this concept that we have used, another concept that we have used. So that's it as far as this question is concerned. We're gonna address another question in the next video. See you soon. You have a good day.